Hello and welcome to EPG Pathshala. This module will discuss on historical evolution of different systems and technologies that contributed to the evolution of digital libraries. The historical evolution of digital libraries has not been linear. Digital library is an eclectic science. Thus, contributions for evolution of digital libraries have come from several disciplines, leading to multiple conceptions of digital libraries, each one influenced by the perspective of primary discipline. History of digital libraries, therefore, is the history of variety of different types of information system and technologies that have been considered as digital libraries or their precursors. These systems and technologies are very heterogeneous in their objectives, scope, and functionalities. As such, their evolution does not follow a single path. It can be observed that most of the systems described in this module are still practiced in one form or another using newer technological solutions and have applications in diverse fields of information management. Development in digital library progressed along with developments in computers and communication technology. The electronic number integrator and calculator computer, also called the ENIAC-1, was built in 1946. It was developed by John Mauchly and J. Presper Eckert at the University of Pennsylvania. It contained over 18,000 vacuum tubes. It weighed 30 tons and was housed in 2 stories of a building. Another computer, EDVAC, or the Electronic Discrete Variable Automatic Computer, was designed in 1947 to store 2 programs at once and switch between the sets of instructions. It contained over 6,000 vacuum tubes, 12,000 diodes, and consumed 56 kilowatts of power. It weighed 7,850 kilos. A major breakthrough occurred on 23rd December 1947 when Bell Laboratories replaced vacuum tubes with the invention of the transistor. The transistors decreased the size of the computer and at the same time increased the speed and capacity. The Universal Automatic Computer, also called UNIVAC-1, became the first computer using transistors and was used at the US Bureau of the Census from 1951 until 1963. Software development also was in progress during this time. Invention of integrated circuit by Robert Noyce of Intel and Jack Kirby of Texas Instruments in 1960s was the turning point that marked the onset of a new generation of computers. Notable reductions in the size of microprocessors combined with dramatically enhanced capacity have added new dimensions to the computer hardware technology. Early small-scale integration efforts first gave way to large-scale integration, that is LSI chips, that contained thousands of components, very large integration chips or VLSI chips that contained hundreds of thousands of components and circuits, and now ultra large scale integration chips or ULSI chips come with millions of components and circuits. The first microprocessor used in a PC was Intel 8080. It was introduced in 1974. It was a complete 8-bit microprocessor on a single chip. The Intel 8088 was used in the IBM PC in 1979. Later on, the PC market moved from 8088, 80286, 80386, 80486, and then Pentium, Pentium 2, Pentium 3, Pentium 4, and now to Intel dual core and quad core. Like microprocessor technology, digital storage devices have also witnessed notable reductions in their size and cost with dramatic enhancements in capacity of storage. There are two types of data storage devices, that is, removable data storage devices and non-removable data storage devices. The early magnetic storage devices were designed to record analog audio signals. Most audio and video magnetic storage devices, including computers, store digital data. Large amounts of data are stored through tape drives because the capacity on the drives is huge. 3 billion or 3 gigabytes of data per square inch can fit on a single magnetic disk. Examples of magnetic storage devices are hard disks, floppies, tapes, cartridges, etc. The compact disc was the first popular optical storage media. It was introduced in 1982. Two versions of CD-ROM were released in 1988. That is, the CD-R, which was write once, read many, which means data once written cannot be erased. And secondly, the DRRW, in which the data once written can be erased completely and the same storage device can be used again for storing different data. A typical disk used in a computer-based CD drive stores 700 MB. Digital video discs or DVD is an optical storage system. It was rolled out in 1996 as a successor to the CD. Recordable formats of DVD called DVD-R were released in 1997 and a writable format called DVD plus R was released in 2002. Commonly used DVDs have storage capacity of 4.7 GB. Flash memory is metal oxide semiconductors based storage devices, popularly known as pen drives or USB drives or flash memory devices. It was patented in 1999 by IBM. USB drive is a non-volatile computer memory that can be electrically erased and reprogrammed. It is a technology that is primarily used in memory cards and USB flash drives for general storage and transfer of data between computers and other digital products. Flash memory stores information in an array of memory cells made from floating gate transistors. Some newer flash memory, known as multi-level cell or MLC devices, can store more than 1 bit per cell by choosing between multiple levels of electrical charge to apply to the floating gates of its cells. Kingston Technology Company has released 3.0 USB flash drives in 2003 with 1 terabyte of storage capacity. Creation and remote accessibility of online databases through information retrieval systems, that is IRS, can be considered as an important landmark and precursor to the digital libraries. The first databases were bibliographic in nature and were online versions of existing indexing and abstracting services such as biological abstracts, index medicus, chemical abstracts, etc. These databases used data files generated in the process of electronic phototypesetting of printed abstracting and indexing services and other primary journals. These bibliographic databases were hosted on mini and mainframe computers, providing remote access and online search and retrieval services to users using computer and communication technology that was available at that time. Dialog became the first commercial online service in 1972. By 1975, there were 300 publicly available online databases. By 1988, 3,893 online databases were available from 1,723 database producers and 506 online services. With introduction of a number of online databases containing textual information, news, statistics, commodity prices, etc., a third type of database, holding text of full-length documents started appearing. Online hosts like Dialog, STN, Blaze, and ESAIRS were not only offering online databases but also full-text online journals for past several years. Although as a simple ASCII or text files without graphics and pictures. In 1989, there were almost 1700 full-text sources in 16 online systems. Several full-text databases also started appearing in the late 1980s and early 1990s, launching the beginning of the digital era. Some of the important full-text digital collections available on CD-ROM include Adonis, IEE and IEE Electronic Library, ABI Info, UMI's Business Periodical on Disk and General Periodicals on Disk, Space World, US Patents, etc. Several software packages were released during the mid-1970s and the late 1970s for computer-based storage, indexing, and retrieval of documents in character-coded form. Some of the better-known text storage and retrieval packages included IBM's Storage and Information Retrieval System called STAIRS, Battle Automated Search Information System called BASIS, Inquire, BRS Search, DocuMaster, Assassin, Status, CARES, etc. MicroCDS ISIS, one of such advanced non-numerical information storage and retrieval software developed by UNESCO in 1985, was used extensively by libraries, especially in developing countries. MicroCDS ISIS is currently available in different flavors, including CDS ISIS for Windows, Gen ISIS, Java ISIS, Webless, WWW-ISIS, etc. Availability of a wide range of database management system or DBMS such as Ingress, Microsoft Access, MS SQL Server, MS FoxPro, MySQL, NoSQL, Oracle, Postgres, SQLite, and MongoDB in the late 1990s and early 2000s also contributed to the evolution of digital libraries. Digital imaging was developed in the 1960s and 1970s to avoid the operational weaknesses of film cameras for use in scientific and military missions. The first digital image was produced in 1920. However, invention of the CCD, that is the charge coupled device, in 1969 at AT&T Bell Labs by William Boyle and George E. Smith led to the development of digital document imaging system which employ computer hardware and software to scan and store images of documents in digitized formats. Major milestones in the history of institutional repositories can broadly be categorized into four major subheads, namely institutional repositories and service providers to harvest metadata from growing number of IRs. Number 2, major catalytic initiatives or movements. Number 3, OAI compliant open source software for IRs. And number 4, publishers' response to IRs. Learners are advised to read the timeline for detailed information on growth and development of institutional repositories from Learn More components of the same module. Launching of Open Archives Initiative or OAI and its Protocol on Metadata Harvesting PMH can be considered as one of the major initiatives that proved as a catalyst to the growth of IRs. The OAI initiative was evolved in the meeting of the Universal Preprint Service held in Santa Fe, New Mexico in 1999 to explore cooperation among growing number of scholarly IRs. The protocol provides an interoperability framework based on the harvesting of metadata. OAI-PMH defines a simple set of metadata that can facilitate federated resource discovery. A number of services were launched to harvest metadata from the growing number of institutional repositories with an aim to provide integrated access to content distributed across thousands of digital repositories and open access journals, and to provide associated service to the users. The important service providers include Cross-Archive Searching Service, launched by Old Dominion University in 2000, OISTER, launched by the University of Michigan Libraries Digital Library Production Services in 2002, and Google Scholar in 2004. While Open Archives Initiative (OAI) is one of the major catalysts to IR's movement, other catalysts to this movement include the Budapest Open Access Initiative, launched by the Open Society Institute in 2002, Project Romeo and Project Sherpa, launched in 2002, and mandating deposition of articles by faculty in open access repositories in the University of Southampton, Department of Electronics and Computer Science in 2003. Availability of a number of OAI compliant open source software for IRs led to widespread establishment of IRs in several research institutions and universities, especially in the developing countries. Some of the important OAI compliant open source softwares are ePrints, SDSware, DSpace, Fedora, etc. Responding to the pressure created by academic community with the spread of open access journals, institutional repositories, authors' websites, several publishers have come out with their policies on self-archiving. Major publishers like Elsevier, Sage, Springer, IEEE, and IEE allow their users to self-archive their research articles in IRs or on author's website. The history of Internet can be traced back to 1957 when the erstwhile Soviet Union launched its first satellite, Sputnik 1, prompting US President Dwight Eisenhower to launch the Defense Advanced Research Projects Agency, or DARPA, to regain the lead in the technological race. The graph shows the historical evolution of Internet technology. However, learners are advised to view the timeline from the Learn More component of the same module to view the details of the history of Internet technology. The advent of the World Wide Web offered a crucial advantage with the availability of ready-to-use, publicly available, user-friendly graphical web browsers for all prevalent platforms. Standard www clients such as Internet Explorer and Google Chrome that are being upgraded regularly for added functionality such as email client, support for Java and ActiveX, and the ability to view important document formats without having to install plugins for them. These browsers solved the maintenance problem, allowing developers to concentrate fully on the server side and not to bother with the client side. In 1945, Bush conceptualized memory extender called MEMEX, a thinking machine in which an individual could store information and link them. In 1962, Engelbart started work on the Augment project, which aimed to produce tools to aid human capabilities and productivity. He developed NLS, or Online System, that allowed researchers in the Augment project to access all stored working papers in a shared journal, which eventually had 1 lakh items in it and was one of the largest early digital libraries. Engelbart is also responsible for inventing the pointing device, or the mouse, in 1968. Ted Nelson designed the Xanadu system in 1965 and coined the word hypertext and proposed a system wherein all publications in the world would be deeply interlinked. The most significant development in the history of internet was the invention of the World Wide Web by Tim Berners-Lee at the CERN Library in 1991. The crucial underlying concept behind the World Wide Web is hypertext that has its origin in Ted Nelson's Project Xanadu and Douglas Engelbart's Online System or NLS. He also developed three essential technologies such as a system of globally unique identifiers for resources on the web and elsewhere, the Universal Document Identifier or UDI, later known as Uniform Resource Locator or URL, and Uniform Resource Identifier known as URI. He also developed Hypertext Markup Language or HTML and Hypertext Transfer Protocol or HTTP. Machine Readable Cataloging or MARC, introduced in 1964, can be considered as a major development in electronic resources. Automation of libraries started in a big way in 1970s with the introduction of integrated library automation packages. The trend picked up in the early 1980s with an introduction of PCs at a cost affordable to the libraries. The computerized catalogs of individual libraries led to formation of union catalogs through library networks like OCLC that were developed to facilitate online and copy cataloging and resource sharing. By early 1970s, library OPACs and union databases were accessible from remote locations. Moreover, online search services like Dialog, Orbit, BRS Search, and Datastar in the USA, Blaze and Pergamon Infoline in the UK, DIMDI in Germany, Euronet and Diane in Europe, ESA IRS in Italy, and CANOLE in Canada, etc., were also made accessible online to the research community. The emergence of Internet and the World Wide Web in the early 90s as a new media of information storage and delivery came as a real boon for the evolution of electronic resources. Internet and web technologies brought in the graphical components in electronic resources and digital libraries that were missing earlier. Internet and web technologies brought in the graphical components in electronic resources and digital libraries that were missing earlier. There has been a steady move up the technological scale for the electronic resources in the late 1980s from early low-end electronic publications available as ASCII files to being organized and searchable on Gophers in the year 1992 and to being tagged and graphically viewable on World Wide Web sites since the year 1994.